Ladies and gents, here's your section 2.2 and 2.3 video. Today we are adding and subtracting integers with rules, and actually we're not even adding and subtracting integers. We're going to do some rational numbers, which as you know means fractions. So let's get right into it. The essential question for today is, how do I transfer my knowledge of positive and negative integers into addition and subtraction problems that include fractions and mixed numbers? Fractions and mixed numbers are trickier. We can't just do piles of positive and negative and do the cancellation like we did before because they're fractions. But I'm hoping that at the end of today, you will understand as well as this baby does. You're going to be fraction experts. So let's look at our first example. Here I have 4 1/5 plus negative 9 1/2. Now keep in mind, let's think about an easier example. Let's think about what we would do if we were adding 4 and negative 9. So I basically just took off the little fractional part of the mixed number. We're really used to doing 4 positives and 9 negatives, and oh my goodness, my pile of negatives is bigger than my pile of positives, so things are going to cancel because plus minus pairs cancel, and I'm left with how many? Looks like 5 negatives, so my answer is -5. Now that's not really going to work with this problem, because in this problem we have fractions, and I don't know how to do a fraction of a plus or a fraction of a minus. So we need to keep in mind the technique but use the general trick. And here's the general trick. Since I know that over here, first of all, my pile of negatives is bigger than my pile of positives, I know that my final answer that I'm going to box at the end down here should be negative. Because I saw with the easier example that since the negative number is bigger and cancellation's happening, when things cancel, I'm going to be left with just negatives because there were more negatives to begin with. Also, since I have one positive and one negative, we saw that things canceled. And since things are canceling, our value, kind of the absolute value, is going to represent a subtraction. Subtraction because I was canceling. So the trick here is that eventually I'm going to want to subtract these two values and then make the result negative because I know my pile of negatives is bigger than my pile of positives. I said eventually because we would do well to convert these into improper fractions first. I don't really know how to subtract with mixed numbers. I want to convert into an improper fraction, which remember is a fraction where the numerator is bigger than the denominator. You might remember a trick, which is to multiply the denominator times the whole number part and then add it to the numerator. So let's do that. 5 times 4 is 20, and then 20 plus 1 is 21. So my improper fraction is 21 over 5. And the reason that works is because this 4 really is 4 over 1. And I'm saying, hey, it's 4 and 1/5. Or in other words, 4 plus 1/5. So I'm going to get my common denominators. 4 with a common denominator of 5 is 20 over 5. And I'm doing 20 over 5 plus 1 over 5 to get me 21 over 5. If that doesn't make sense to you, think about it, maybe pause and rewind the video. It should, but otherwise you can always just use your trick to get the mixed number. Let's do the same thing with this -9 1/2. I'm gonna multiply the denominator times the whole number part and then add it to the top. So 9 times 2 is 18, plus 1 is 19, so I have 19 over 2. Now, in order to combine these two fractions, you know that I need, since I'm adding or subtracting in this case, that I need a common denominator. That common denominator is going to be 10. So let's multiply this guy by 2 over 2. That would give me 42 over 10. Let's multiply this guy by 5 over 5. That's going to give me 95 over 10. How's that for mental math? Now remember, I said that I need to subtract these fractions, and the reason I'm subtracting is because cancellation was happening. So I'm going to go remember, I'm just doing the numerators. I'm going to ignore the fact that the 95 is negative and the 42 is positive, and I'm just going to go 95 minus 42, and that is 53. So my final answer is going to be 53 over, of course, I keep the denominator 10. And again, the reason why I chose negative at the very beginning of the problem was because this negative value is bigger, so when the cancellation happens, I'll be left with negatives. Nice. Let's go to actually an easier example. This one only involves fractions, no mixed numbers, so I just need to find a common denominator, think about what rules are applying here. Now, I have definitely a negative, because remember, this is the same as 1/3 plus negative 2/5. And I have one positive. Since I have one positive and one negative, here's another situation where the piles, some things are going to cancel, and so I need to subtract. So let's just work on getting a common denominator and we can subtract. Let's see, I think the common denominator will be 15. So I'll multiply this guy by 5 over 5, so 5 over 15. I'll multiply this guy by 3 over 3, so 6 over 15. And I'm going to subtract, again, the numerators. I'm subtracting because I know my piles of positives and negatives are going to cancel. When I do 6 minus 5, I get 1, and that's over 15. But now I need to ask myself which pile was bigger to begin with. And in this case, it's clear that the 6 over 15 pile was bigger. That was negative. So when all of the carnage and the cancellation is done, I will have negative 1 over 15. Are we feeling like that baby? Are we feeling like we love fractions? I hope so. Let's do one last one. Here I have a negative 5 halves and I'm adding a negative 11 over 6. Remember, subtracting is the same as adding a negative. So in this case, because I have a negative here and a negative here, remember what that looks like with the piles. Let's say I had negative 3 plus negative 2. This was 3 negatives, this was 2 negatives. The piles are adding up. There are 5 negatives total, so my answer would be negative 5. In other words, my piles are combining instead of canceling, so I'm going to choose addition. But since my piles are all negative, shouldn't my final answer be negative? So I'm going to kind of add these guys together, but keep the negative. So let's get a common denominator. It will be 6 in this case, so multiply this first fraction by 3 over 3. That's negative 15 over 6 plus negative 11 over 6. Cool, and I said that when I have two negatives, I sort of need to add the values together. So I'm doing 15 plus 11. That is 26. So my final answer is 26 over 6. Again, I chose negative because I have two piles of negatives here. Now don't forget, I need to reduce this fraction, so let's unbox this answer and reduce. It looks like I can divide the top and the bottom by 2, so my final answer is negative 13 over 3. Final answer. Alright guys, just a summary, keep in mind when the signs are the same, like plus plus or minus minus, that means you need to add the values. You're just going to keep the sign then. So if I'm adding a positive with a positive, my final answer is definitely going to be positive, and my final answer for the negative plus a negative is definitely going to be negative. But when the signs are the opposite, you need to subtract. And remember, the reason we're subtracting is because I know the pile of positives and the pile of negatives are going to cancel with each other. I'm taking the sign of the larger value because after all the cancellation happens, the sign will be whichever pile has the most left over. So if you're adding a positive to a negative, I don't really know. It could be a positive if the positive was bigger, or it could be a negative if the negative was bigger. You have to choose. All right, thanks for watching.